This question is a review on percent yield and asks if the percent yield for the following reaction is 65%, how many grams of potassium chlorate are needed to produce 42 grams of oxygen? So the first thing that we're going to do is balance this equation. Definitely every time you see an equation on homework and exam, that's the first thing you want to keep in mind. So I go more into it in a previous video, but this one is pretty quick. I'm just going to make a table over here so I can keep track of what I have on my left and right hand side. So I have 1 potassium on my left and right, and similarly I can fill in the chart for chlorine and oxygen. So oxygen is what I need to balance, and it's nice that I have this O2 here because I can manipulate this stoichiometric coefficient without impacting how much potassium and chlorine I have. So what I'm going to do is a trick I like to use, which is to put a 3/2 in front of this O2. And we have 3 over here, we need 3 on our right hand side. So this is just taking 3/2 of 2 oxygen atoms, because this is diatomic, to get 3 oxygens. If you are going to use this, always make sure you have no fractions in your final equation. So I'm going to multiply this entire thing by 2. And I'm going to get that this is our final equation. And now that I've done this, I'm going to make sure to update my chart. So now we have 2 potassiums on each side and we're balanced there. We have 2 chlorines. And we have 6 oxygens. So we are totally balanced. And now that we are balanced, the next thing is to use the percent yield formula to find the theoretical amount of oxygen we can produce. And this is based on the problem statement because we know we have 65% yield. We know we have the actual amount of oxygen produced, and then that allows us to find the theoretical amount that we produced. And we want to find that theoretical amount because we're dealing with conversions based on stoichiometric coefficients from our balanced equation. And so when we're doing that, we need to know theoretical amounts to find, for instance, the amount of potassium chlorate needed. So we can just remind ourselves what the percent yield formula is, which is the actual amount we produced over the theoretical amount we could have produced times 100. So to find the theoretical amount of oxygen, we take 65, which is our percent yield, which equals 42 grams of oxygen over theoretical times 100. And I get that the theoretical amount is 64.6 grams of oxygen. And so now that we have that, we want to work in moles so we can convert between species. So I'm going to convert this amount of oxygen to moles of oxygen just by using the molar mass. And make sure you realize this is diatomic, so this is going to be 32 grams. And I get 2.019 moles of oxygen is what we theoretically could have produced. So the next thing that we can do is find the grams of potassium chlorate needed. And we just use this using the coefficients in our balanced equation. So we have 2.019 moles of oxygen, and we can convert this to moles of potassium chlorate based on our balanced equation above, which says that for every 3 moles of oxygen that are produced, 2 moles of potassium chlorate are consumed. So using that relationship, we get that we need 1.346 moles of potassium chlorate. And we want our answer in grams, so we're just going to use the molar mass to do that. So we have 1.346 moles of potassium chlorate. We're going to multiply by 122.55 grams per mole of potassium chlorate and get that 165 grams of potassium chlorate is needed to produce 42 grams of oxygen.